In this episode, we start by taking two terms that get tossed around as if they are automatic solutions and turning them into clear, careful ideas: tokenization and truncation as ways to minimize PCI scope. Beginners often hear that tokenization or truncation can shrink the cardholder data environment, CDE, and they assume that simply choosing one of those approaches makes cardholder data disappear from their world. In reality, these techniques can be extremely effective, but only when you understand what problem they solve, where in the payment flow they happen, and what data still exists after you apply them. Scope reduction is not about hiding data. It is about designing the environment so that fewer systems ever touch the sensitive parts of cardholder data in the first place. When you understand tokenization and truncation properly, you can reason about which systems remain in scope, what controls still matter, and what evidence would show that the reduction is real. That kind of reasoning is high yield for the ISA exam because it combines data flow thinking, scope boundaries, and control intent into one coherent story. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A strong first step is defining tokenization in plain language, because people sometimes confuse it with encryption or with masking. Tokenization is a process where a sensitive value, like a primary account number, PAN, is replaced with a token that has no meaningful value by itself. The token can be stored and used later to reference the original value, usually through a secure service that can map tokens back to real card data when needed. The important part is that the token is not derived in a way that lets someone reverse it on their own, which is why tokenization can reduce the presence of card data in many systems. If your business systems only store tokens, those systems may no longer store cardholder data, which can shrink scope and reduce risk. However, tokenization shifts the sensitive concentration to the token service and whatever systems still handle the real PAN, so the question becomes where that service lives and how it is protected. Truncation is a different idea, and beginners often mix it up with masking because both involve showing only part of a card number. Truncation means permanently removing part of the PAN so that the full number is not stored, such as keeping only the last few digits and discarding the rest. This can be useful for receipts, customer recognition, and reconciliation because partial digits can help identify a card without exposing the full number. The key is that truncation is not reversible, which is what makes it powerful for scope reduction in storage contexts. If a system never stores the full PAN, it cannot leak it later, and that reduces the impact of a breach. But truncation also has limits, because many payment operations require the full number at the moment of authorization, so you still need a secure way to process payments without relying on truncated data as if it were the real thing. To use these techniques wisely, you need to connect them to the payment data flow, because scope reduction depends on where the sensitive data travels before it is transformed. If the full PAN enters your environment, gets stored in your application logs, and only later gets tokenized, you have not reduced scope as much as you think, because the early systems still touch the data. The most effective scope reduction happens when the environment is designed so that the full PAN goes directly to a controlled component, such as a payment gateway or tokenization service, and then the rest of the business systems receive only tokens or truncated values. This is why mapping end-to-end data flows matters so much, because tokenization and truncation are not magic words. They are steps in a journey. A wise design makes those steps happen as early as possible and prevents accidental copies from being created along the way. When you can explain how the flow changes before and after these transformations, you can defend the scope reduction logically. It is also important to understand what tokenization does not automatically fix, because there are still risks that can keep systems in scope even if they store tokens. If a system can influence the security of the tokenization process, such as by controlling configuration, access, or logs, it may still be considered could impact even if it does not store the PAN. If tokens are accepted by downstream systems as if they were safe for any purpose, people can accidentally treat them like public identifiers and spread them widely, which can create operational risk and, in some cases, security risk, depending on how the token system works. Also, tokenization does not automatically prevent cardholder data from appearing in logs, error messages, and screenshots if people mishandle inputs or debugging. Scope reduction requires disciplined handling practices, not just a token service. A wise approach pairs tokenization with strong controls around where card data can appear and how systems are allowed to interact with the token service. Truncation has its own misconceptions that beginners should correct early, because it is often misunderstood as a kind of lightweight encryption. If you truncate correctly, you have removed data, so there is nothing to decrypt, and that is why it can reduce risk. But truncation does not help if a system still receives the full PAN and simply displays only part of it, because the full value still existed in memory, in logs, or in temporary files. Another common mistake is thinking that storing a truncated value plus other related data is equivalent to storing the full card number, which is not true, but it can still create privacy concerns and must be handled responsibly. Truncation is best seen as a storage minimization strategy, not as a processing strategy, because payment authorization still requires the full data at the right point in the flow. When you understand truncation as a way to avoid storing full values, you can place it properly in the environment and not expect it to do more than it can. Another part of using these techniques wisely is recognizing how they affect business processes, because security and operations must stay aligned. For example, a business might need to perform refunds, recurring billing, or customer account updates, and those workflows influence whether tokenization is needed and what kind of token is appropriate. Tokens can enable operations without storing the full PAN, but only if the systems are designed to use tokens correctly and the token service can support the needed payment actions. If a business tries to rely on truncated numbers for tasks that require full card data, people may invent unsafe workarounds like asking customers to email card details again. A wise scope reduction strategy anticipates business needs and uses tokenization to support them safely, while using truncation for display and record keeping where full numbers are not necessary. When security design supports legitimate workflows, it reduces the temptation for dangerous shortcuts. To reason about scope, you should get comfortable with a simple question. After tokenization or truncation is applied, which systems still see the full PAN, even briefly? Those systems are still part of the CDE or directly connected to it, and they require strong controls. Systems that never see the full PAN and only handle tokens or truncated values may fall out of the CDE, but you must still consider whether they could impact the security of the CDE, such as by controlling access paths, configurations, or integrations. This is where beginners sometimes oversimplify scope reduction as a yes or no decision, when it is more like moving the boundary and tightening it. The goal is to reduce the number of systems inside the boundary, reduce the number of trust paths into it, and reduce the number of places sensitive data can be copied. When you describe scope reduction this way, it becomes a logical outcome of design choices rather than a marketing claim. Evidence is a major theme here, because PCI expects you to show that tokenization and truncation are doing what you claim they do. Evidence is not just saying we use tokens. It is showing that business systems store tokens instead of full card numbers, and that any stored card-related values are truncated according to policy. Evidence also includes showing that the token service is the controlled point where real card data is handled and that access to it is limited and monitored. It includes showing that logs, reports, and exports do not contain full PAN values, which is often where accidental storage happens. The evidence story should match your data flow map, because the map claims where data goes and what transformations occur. If the map and the evidence disagree, scope reduction is not proven, and that is exactly what an assessor will challenge. You should also understand the risks of doing tokenization or truncation poorly, because that helps you recognize the difference between real reduction and cosmetic reduction. If tokens are generated in a predictable way, or if they are stored alongside data that allows easy mapping back to the PAN, you may not have reduced risk meaningfully. If truncated values are stored in places that still hold the full value elsewhere, like backups of the original data store, the environment still contains cardholder data. If people can bypass the token service by entering card data into general business systems, The scope reduction can be undermined by human behavior. These are not reasons to avoid tokenization or truncation. They are reasons to treat them as part of an overall system of controls, training, and validation. Wise use means looking for these failure modes and designing to prevent them. Finally, it helps to connect scope reduction to a broader security mindset, because the best outcome is not just a smaller scope, but a safer environment overall. When fewer systems touch sensitive data, there are fewer places for attackers to steal it and fewer opportunities for accidents. When the handling of cardholder data is concentrated into a controlled component, the organization can invest more strongly in protecting that component rather than spreading effort thin across dozens of systems. Tokenization and truncation are tools for creating that concentration, but they must be paired with strong access control, monitoring, and careful data flow design. They also need ongoing checks, because changes to applications, logging, or integrations can reintroduce full PAN values into places that were previously clean. Scope reduction is a benefit, but risk reduction is the real goal, and wise designs accomplish both. By the end of this lesson, the key takeaway is that tokenization and truncation can meaningfully minimize scope, but only when you understand what they are, where they happen in the payment flow, and what data still exists afterward. Tokenization replaces the PAN with a token so business systems can operate without storing real card numbers, while truncation permanently removes digits so full values are not stored where they are not needed. Both techniques work best when applied early and supported by discipline that prevents accidental copies in logs, files, and reports. Scope reduction must also be proven with evidence that matches the data flow story, including showing which systems still handle full card data and how the controlled components are protected. When you can explain these ideas clearly, you are ready to answer exam questions that test not just definitions, but judgment about what truly reduces scope and why.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.